This week, the CEO of Anthropic, the creator of Claude language model, Dario Amodei, predicted that within 6 months, 90% of all code will be written by AI. Whilst at the same time, the concept known as vibe coding has risen to be one of the most searched for terms in AI, even overtaking prompt engineering on Google Trends, with many thousands of videos, blogs, and discussions taking place on this new way of building software. And then you have AI startups like Cursor, who has grown 9,900% in 12 months alone, being one of the fastest companies ever to reach 100 million in revenue. Clearly, the way we build software is changing, but how fast that change will take and the future role of developers is still a hotly debated topic. This is perhaps one of the most competitive and important implementations of AI in the world. Technology that can build technology. In today's episode, we'll discuss the CEO of Anthropic's claim, the rise of vibe coding and what it could mean for business and technology. This is In the Loop with Jack Horton. So let's start with the actual clip itself from Dario Amodei, who's the CEO of Anthropic, where he puts this vision of the future, or the very near future, for programmers. So this was at the Council of Foreign Relations event, and I think I'll just play the clip, so have a listen.
We can build a world where human life is meaningful and humans, perhaps with the help of AIs, perhaps working with AIs, build really great things. So I'm actually not that pessimistic. Getting to kind of the job side of this, I do have a fair amount of concern about this. On one hand, I think comparative advantage is a very powerful tool. If I look at coding, programming, which is one area where AI is making the most progress, what we are finding is we are not far from a world, I think we'll be there in 3 to 6 months, where AI is writing 90% of the code. And then in 12 months, we may be in a world where AI is writing essentially all of the code. But the programmer still needs to specify, what are the conditions of what you're doing? What is the overall app you're trying to make? What's the overall design decision? How do we collaborate with other code that's been written? How do we have some common sense on whether this is a secure design or an insecure design? So as long as there are these small pieces that a human programmer needs to do that the AI isn't good at, I think human productivity will actually be enhanced.
So, of course, in that clip, he's claimed that almost all code is going to be written by AI in less than a year, which is a huge claim. Now, it's really important to take this with a pinch of salt because they're finalizing a $3.5 billion round right now. And a big part of their hype is actually that they're the LLM of choice for programming. So all those tools that are building on top of language models, the users of those tools are actually choosing Claude to build code. So, obviously, this is a big part of their investment narrative. And also importantly, they've just brought out Claude Code, which is a coding agent. So again, obviously, it's a massive benefit when someone on a major stage makes this big claim that makes the media, as it's done, go a bit crazy. It's only going to drive their valuation, their market share up. And to be honest, if you only look at financial metrics, then there's probably some argument that this level of adoption is maybe possible. Probably quite ambitious, though. Let's take Anthropic. It was last valued at about $18.5 billion in 2024, so that's February 24. And now they're valued at over $60 billion in March 25. So that's a huge leap in valuation in just 12 months. And they've 10x their revenue, so they've gone from $100 million to $1 billion in revenue. They're also backed by Google and Amazon, so that's massive distribution for their language models. And Amazon Alexa has actually chosen to use Claude as their language model too. Now you can see why some people, and particularly investors, are very excited. The idea that you could automate much of the building and the programming of technology is obviously something that's really compelling because it's very expensive and very time consuming to build a product with engineers. There are a lot of important counter arguments and criticisms of this narrative, which I will cover throughout the episode. But a key reason I think this interview's gone so viral is because of the rise of vibe coding. It's blown up around the world in the last, say, 3 to 4 weeks, and I think encapsulates a lot of the arguments both for and against this idea that programming as we know it is over and will suddenly be done by AI. As I said earlier, vibe coding as a search term has now been searched for more than prompt engineering. So that's a huge increase out of absolutely nowhere in about a month. So let me explain vibe coding. So the term vibe coding came from Andrej Karpathy, who's a very notable figure in the AI space. And he said, and this is an actual quote, "There's a new kind of coding I call vibe coding, where you fully give in to the vibes and embrace exponentials and forget that code even exists. It's possible because the LLMs, so Cursor Composer, the program building tool, with Claude, the language model, is getting so good. And I just talked to Composer with Super Whisper, which is a voice-to-text tool. So I barely even touch the keyboard anymore. I asked for the dumbest things like decrease the padding on the sidebar by half because I'm just too lazy to find it. I just accept all. When I get error messages, I just copy and paste them in with no comment, and usually that fixes it. The code grows beyond my usual comprehension, and I have to really read through it for a while. Sometimes the LLMs can't fix a bug, so I just work around it or ask for random changes until it goes away. It's not too bad for throwaway weekend projects. I just see stuff, say stuff, run stuff, copy and paste stuff, and the app mostly works. So that's vibe coding. Using these AI applications such as Cursor to quickly and easily just build an entire piece of software. And soon after this idea was floated, it got picked up by entrepreneurs, investors, the media, and particularly those at Y Combinator, who actually made a video about it, and I'll cover many of their points because I think it's quite interesting. But they discussed it as if it's the next big wave in programming. And their viewpoints were fueled by the conversations, interviews, and actually their recent survey of their Y Combinator entrepreneur batch. Obviously, that program they run is full of most of what will become some of the most successful tech businesses in the world, and they produced a lot of the biggest tech companies in the entire world. So let's talk through what they learned from those interviews and survey results. So in the video, they discussed how a founder said they suddenly feel a lot less attached to their code, because if you can get a new version of the same feature in just a few minutes, why would we spend hours polishing code? And this is a massive shift from this usual pride of a fantastic developer in building a code base that's fantastic. And with this in mind, the video discussed how vibe coding may change the way developers are even hired and how technical interviews for developers are going to be ran. Because instead of challenging them on their knowledge of, say, data structures, you could imagine a more practical exercise. So going to the interview and say, use this AI environment to build a small application and show us your process and do it really quickly. And suddenly the candidate's ability to direct that AI effectively and produce something that can be used is going to be what is scored highly. And there was even discussions that if software runs and meets a need, the underlying code can just be discarded or just improved and recreated on a whim. And there's a big narrative around the YC batch of the ability for people to suddenly go from 0 to 1 is growing exponentially. So suddenly you can have an idea for a feature or a workflow or a use case, and you can get it spun up and in front of real users and customers really quickly. So if this feature happens and if vibe coding continues to grow in popularity, developers are probably going to see their role morph into something akin to agent management. And you could probably argue this is starting to happen already. Google's CEO reported that around a quarter of Google's new code is AI generated. When you listen to those arguments, it's easy to get carried away and think that suddenly it's the end of programming or people are going to suddenly get sacked and things are going to change really quickly. But it's also important to preface that there's a lot of criticisms against this approach and the technology is still really early. For example, our team at Mindset have found many of these tools that people have been raving about crap. Many people have also said that it might work really well for small-scale experiments, but when you come to massive user bases, very complex projects, or even regulated industries like finance or healthcare, it's just not going to work the same. Because who's the one that's going to check whether it's 100% secure? Or when it comes to debugging, it's one thing to ask an AI for a feature, but what happens when you run into an error that you don't understand or the AI can't fix? A common strategy is often to just copy and paste the error message back to the AI and hope it's fixed. But often this just doesn't work. And a lot of the momentum and energy behind vibe coding has also come from people that are non-technical. So this idea that suddenly I can just build things and I don't need to actually learn how to code. When in reality, being an expert in your craft, as we'll discuss in the next part of this podcast episode, is going to be even more important. And the idea of just letting AI balloon a code base and basically make it into spaghetti code that nobody could ever understand probably would leave a lot of people confused and concerned. So there are many issues with this technology, of course, and I'm sure it's going to improve. But these criticisms don't really answer the question of what the future role of a developer will be. And this is where it comes to what I think is the most compelling argument by Tim O'Reilly. O'Reilly starts by describing how computers have, from the very beginning, been a story of continual automation abstraction. So this is the process of simplifying what was previously very complex and then allowing programmers to operate at a simpler view of a system. So I'll give you an example. The first ever programmers physically connected circuits together so a computer could then perform a calculation. And they were eventually succeeded by programmers writing machine instructions as binary code, so that's ones and zeros, and then flipping switches on the front of a computer. Assembly language then put all that to bed and simplified it all by providing essentially an out-the-box system that meant people didn't need to worry or think about ones and zeros. It suddenly let a programmer speak to a computer in a more human-like language, to tell a computer to move data to locations in its memory and then perform calculations on it. But then soon higher-level languages, so C and eventually Java, removed programmers from even that level of detail. So the best way of thinking about this is that each new innovation is then packaged up into something that's almost out the box, so future programmers don't need to think about it. And that's where O'Reilly explained that each step has led to claims by some in the world that we're seeing the end of programming as we know it, because code was just suddenly so much easier to write. But at every single step, the demand for programmers went up, not down. And this is because every time you make programming easier, you also expand its potential and its reach. People who would have never tackled ones and zeros or assembly level tasks suddenly could just write an entire application. And companies realized they could automate processes that seemed previously far too big to handle. And it's a pattern that keeps on repeating. O'Reilly also pointed to the advent of, say, consumer operating systems. So this is Windows and Mac OS, and how they actually cut down low-level work even more. So developers didn't need to craft specialized, say, drivers so that software could work with hardware. The operating system provided tools, systems, APIs that allowed you to just build software that worked with hardware. And that didn't reduce the number of developers, it increased them. There were now more people building more applications for more users using new specializations in the process as well. And then suddenly came web, which introduced HTML, CSS, JavaScript, which are languages that are still popular today. Then tools like WordPress or website builders that help non-coders create entire websites. But again, if these tools were so empowering and diminished the role of a programmer, why did the programming role not become obsolete? Because importantly, demand exploded. People wanted increasingly complex sites, so suddenly more specialized tasks were developed by developers. So this is a point that I've discussed in many different podcast episodes, that economic concept which talks about the elasticity of demand, which is when the price of producing something falls, people consume more of it. And in software terms, the more we automate and abstract and simplify, the cheaper it becomes to experiment with new ideas. And as a result, there's just more ideas people want to try. Suddenly building a custom e-commerce website or a mobile app is something more people can do. But this then creates even more complexity that requires more specialized roles, for example, on security or user interface or payment systems. So coming back to AI-based coding, the cost and time for, say, generating code might plummet, but that's likely going to mean more, not fewer, software projects. So the actual impact is that I think the developer's role is going to change rather than end. And as you know, I love a historical analogy, and O'Reilly did a fantastic job of this. He actually referred to the Industrial Revolution's early textile mills. Now, I actually made this analogy 2 episodes ago when I discussed the CEO of Microsoft's view on why everybody was wrong about artificial general intelligence taking over the world. So I'd recommend to go check that out. Anyway, in those early textile mills, skilled craftspeople who were making these things by hand were suddenly disrupted by machines that let less trained people produce cloth quicker. And of course, you can imagine, it looked like the end of the craft. But as time passed, new roles would appear. People who maintained and improved the machines. You had entrepreneurs who explored new ways of applying these machines and textiles to a bigger market. Maybe to produce cloth faster, cheaper, and for people that have never had access to cloth. So this very real world example reminds us of how technology can crush one job description but create another one. And in those examples as well, it took 50 years for both sets of people, so the less trained people using machines and the people handcrafting cloth. It took 50 years for wages to generally rise. Because it took about 50 years for people to actually innovate to apply all these innovations across the entire economy. This doesn't just happen overnight because you see things in the headlines. This will take a long time. Now, in this instance, it may happen much quicker because we have the distribution of the internet. We have lots more skilled people. We have the ability to deploy AI in every piece of software really quickly, but it is still going to take a long time. And really importantly, in software, every wave of automation has a similar outcome. One barrier is removed, say like memory management for a computer, hardware, software interfaces, and then developers will just face another set of tasks that pushes them to a higher, more abstracted, strategic, creative level of engineering. To summarize, I think we should really consider this revolution as a reinvention of programming, not the end of programming. If coding languages first freed us from, say, flipping switches, and operating systems freed us from managing hardware drivers, and no-code tools freed us from millions of lines of boilerplate code, AI might free us from simple code generation. And the important question for all of us is, what will that new layer of complexity look like? Think about all the computational problems that just never have been solved. Climate modeling, real-time disease tracking, large-scale education solutions, advanced robotics. Automating code creation doesn't solve any of those problems. It just makes it much cheaper to start attempting them. I feel privileged to be part of this revolution and cannot wait to be a part of it over the next, say, 10 years, either seeing or being a part of many labs, startups, and teams that are going to figure these things out. In most cases, when we see comments or headlines in the papers that say X changes everything, and whatever X is, it's just important to reframe this as X changes the trajectory of something. And AI coding is something that will shape the trajectory of how technology is built and therefore how the world really functions over the next 20 years. Now, I want to leave you with something really interesting. I'm going to play a few clips from children in the 1960s predicting the future. I think it'll give you some perspective. Before I do, please share this episode with a friend, a colleague, maybe a pet cat, whoever might enjoy it, and even share it to someone else. Anyway, I'll see you next week. Stay curious and have a listen to these clips.
Well, in the year 2000, I think I'll probably be the spaceship to the moon dictating robots.
But I think that there is going to be all this automation. People are going to be out of work and a great population, and I think something has to be done about it. I think it'll be, people will be regarded more as statistics and as actual people.
So I think sort of all machines everywhere, everyone doing everything for you. You know, you'll get all bored, and I don't think it'll be so nice.
I think it'll be much more efficient. Because there'll be more cures for the diseases and not so many people will get sick.
I'm not looking forward to living in that year, about 50 years' time. I mean, the world seems to be in such a terrible state now, let alone in 50 years' time.